Good afternoon, everyone. My name is Shani Gershtein. I'm happy to be here, and thank you for having me here. ניקח את המיקרופון. מה? לא טוב? שומעים? ייי! הכל בסדר? לא, אני בסדר ככה. תודה רבה. So, good afternoon, everyone. I'm happy to be here, and thank you for coming to this session. I'm going to talk about unsupervised machine translation and how to incorporate it with a chatbot. So, my name is Shani Gershtein. I'm an NLP data scientist at GE Healthcare. I'm working on a medical chatbot. I'll show you a short example for it in a bit. And I'm also a volunteer program manager at Ba'ot, which, if you're not familiar, it's the Israeli largest community of senior women in R&D, and I'm helping fellow data scientists to find their next dream job. Also, I want to invite you in this opportunity to join the Israeli NLP community. It's a new one. We can discuss their recent papers, share some open positions, and talking about relevant issues from NLP. So you all know that NLP is cool, but I think unsupervised machine learning is, unsupervised machine translation is cooler. And I want to share with you some of the questions I thought about when preparing this session. So why do we need to translate anyway? And how to incorporate it with the chatbot? And what we at GE are doing with the chatbot and unsupervised machine translation. Talk about the differences between supervised and unsupervised machine translation. I will share some open source, not by us, but implementations that you can use and look for. And of course, the current state of the art. Also, we'll discuss some really cool project of distance language and evaluation metrics. So I want to share with you, I want to start with a question, actually. What if we could all talk one universal language? And what if we could all communicate and understand each other flawlessly? And what if we could have one tool for it? So, sorry, it's not working. Okay. So in the coming years, we're also going to see a lot of chatbots in all of our lives aspects. And it's really important, and we can see it only from this past month's headlines. So New Zealand has their first AI police officer, which greets the visitors to the stations and help them navigate to the station. Another application by Uber, actually improvement by Uber, is launching in-app messaging translation. Over 100 languages. Chatbots that help students to help them to apply financial aid requests. And I can't avoid mentioning the coronavirus and our need for information about it. And it's occupying a lot of ministries, and they want to share information with their citizens, and they need to translate it. Also, we have another chatbot for this problem. So just to give you the last research market report about machine translation market value, it's really increasing in the past years. And the predicted value for 2025 is almost double itself by last year. And so at GE Healthcare, I'm working on a medical chatbot, and I mostly account for the dialogue management and the generation part, which Navot mentioned before, and I want to show you a short video about our product.
Meet the virtual collaborator in development by GE and Roche. We are designing an intelligent digital teammate that frees clinicians to do what they want and need to do. Ask the virtual collaborator what you need in order to care for your patients using voice or text. Its natural language processing is designed to provide unique conversational access to the information you're looking for. It understands your requests and presents the data in a meaningful and clinically relevant way. The virtual collaborator is an intelligent team member who gets you and participates in the care conversation. The virtual collaborator helps clinicians be more present for their patients while enhancing team collaboration and collective clinical awareness. It frees clinicians to do what they want and need to do. The virtual collaborator in development by GE and Roche.
So I hope you heard this is the sound, but I want to dive deep into the chatbot environment. And so the English chatbot, our chatbot, contains three components. One of them is the understanding. And just the session before me, we heard about how difficult it is to understand the language, the intent of the user. And we also have the dialogue management part, which is responsible for connecting to a database or different APIs to get the data. And we have the natural language generation, which is responsible for sharing the response with the user. So let's take a look at this example. What is this patient blood pressure? And we are the understanding part is getting that the user wants to fetch data, and the data is the blood pressure for the specific person, which is the patient. And after we run our English flow, we get the response. Okay, the response is the blood pressure of this patient is 120/70. So when we are facing Spanish utterance, for example, we want to translate it. So the first place to work with the machine translation model is before the understanding part. So we would like to translate the Spanish utterance to English. And then we want to run our whole flow in English, because training a new language bot is really expensive, both time and effort-wise, because we need a linguistic expert, which needs to be also doctors in our case, to annotate the data. So we want to keep our English bot as is. So the next phase is to translate the response we get out of the bot to Spanish, to the user native language. So this is the environment. And now let's take a look of some of the models we have. So first, let's talk about the approaches. So we have supervised approach, which we need parallel corpora, which means that we have the same content in different languages. We can see here the books, it's the same exact content. We can see it in Hebrew, English, and Spanish. On the other hand, we have the unsupervised method or approach, which contains monolingual data, which are different sets of data. It could be news reports, it could be movie reviews per language, and they don't have to be connected by content. So I really like this quotation of Ken Liu. Every act of communication is a miracle of translation. And I want to show you two approaches for unsupervised machine translation, which are kind of doing some magic. The first method is by Facebook AI Research Group. Most of you probably know the name of the researcher Appel. And they have three components for their method. The first one is word-by-word translation, and I will dive deeper to this method in a bit. After we are getting the word-by-word translation, meaning every word gets translation, we will improve this translation by using the language model. This will improve our results by substituting words and changing the order of the words. And after that, we have a back translation part. These two phases are iterative, and actually in back translation, we are taking the language model results and train the other language with this translation. So just to tell you more about the word-by-word phase, they took two word embeddings, one for each language, and they did some linear transformation to rotate the word embedding, to place them one on top of the other. And they then, by finding the k-nearest neighbor, they found that each word translation. So it's really cool method, and the fundamental assumption here is that all languages, sorry, all of our words are similar. All the physical word is similar. So we are referring to things the same in every language. Afterward, they found that that's not true for a couple of distance languages, but we'll talk about it in a bit. So we can see this illustration for 3 languages and the transformation they did for the word embedding. So just linear transformation and finding the k-nearest neighbor as the translation candidate. So here is another example for this process. So we had this first word-by-word translation to English. Afterwards, we improved it by the language model. So here we can find which is turned to what is, and afterwards we have the back translation, which is an iterative process to improve the second language translation model. So what can we improve here? So the performance for distance languages, as I said before, weren't so good, and the next method I will show you solved it. Also, we have some ambiguity because words without its context are we can't be sure that this is the right candidate for translation. The second method, called MAS, it's mass sequence-to-sequence pre-training by Microsoft Research. They train a universal framework that pre-train both the encoder and the decoder. And they randomly masked some of the sentence. We will take K as the number of words that were being masked. And then they try to predict in the decoder the masked word from the encoder. They compare the method to BERT and GPT by using different kind of K. So when K equals 1, it's similar to BERT, masking only one word in the encoder and predicting it in the decoder. And when masking the whole sentence, it will be equivalent to GPT. By adjusting the K number, they got different performance per K, and most of the best results they got where they had 50% each. So blue score, you might know this method of evaluation. It's a string matching algorithm. So we are comparing our translation to the human reference translation, and we are checking how many of our n-grams exist in the reference. And the order matters, and the exact words are matters. So for this sentence, for example, we will get really low blue score because we didn't find any match. This one is slightly improved. We can see 2 grams and also 1 gram until we get to the best solution. So back to our the methods that I've presented. So Facebook and Microsoft are being bold here. The database, the benchmarks they use to evaluate it are News 2014 and News 2016 for English, French, German and Romanian. And we can see a huge improvement by mass over this last year by over 10 to 50 points, which is huge improvement for a blue score. You can see that between 2017 and 2018, until Facebook, they only improved the blue score by 1 or 2 points. So our next topic will be to see an implementation of this process and some of the advantages and challenges. So do you familiar with the Pidgin language? It's a West African language, which is really, it's being used in over 75 million people in Nigeria alone. There are over 1,000 languages across the West and Central Africa. And but this one is the common language to communicate around West Africa. So in the past few months, they found a solution for translating Pidgin to English and vice versa. And it's a really communicated project. You can see here the sentences in Pidgin. It looks like English, but it's not. You can't really understand any of it, but we can see their result. So their blue scores are around 8 or 7. And if you remember the last slide of comparing solutions, we saw that we started English and French and German languages with 15. So it's only the start of the way for Pidgin to English, but it's really an exciting project. So if you want to use unsupervised machine translation with the bot, there are some challenges you need to consider. So utterances won't always be formatted in a grammatical form. So utterance could be 1 word, or it could be 2. Especially in our domain, we are seeing it, that doctor is saying, show me, blood pressure, or just give me that, and not anything else. So we won't be able to rely on the language model to have the translation improved. And also we will need, especially in the clinical domain, we will need to maintain a custom bilingual dictionary. It's a one-time effort of supervised translation, but if we want to have a clinical and professional way of describing diseases or medications, we will need to have this static bilingual translations. On the other hand, the advantages, so we have time and cost saving. I mentioned it before. We will save a lot of time by using, but not using the linguistic expert, and using the same existing bot. And also another advantage is that we get the same performance for supervised machine translation. So just to summarize the process, so we talked about how our world is changing fast, and we demand for multilingual solutions, and chatbots are a part of it. And I presented 2 methods, one by Facebook, which was the state of the art up until 6 months ago, and the other by Microsoft, which is the current state of the art. And in practice, we saw the blue score, which It's the most popular way at the moment to evaluate translations, and the Pidgin to English project, which is a really exciting project. So we are in an exciting era with developing multilingual chatbots to support our need to grow and communicate with different parts of the world. And I hope you noticed that I'm really excited about this domain, and I'll be happy to talk with any of you who are researching this domain as well. Thank you.